Hello and welcome to another Tycho video. In today's presentation, I am going to be walking through the steps on how to install and configure the Tycho software. Now, although I will be doing this on the Mac platform, the process is the same on Windows. So with that, let's go ahead and get started. The very first step is to download the software, and once we've done that, then we can proceed to install it. So the way this works on the Mac platform is to double click on the disk image, and when you do that it will present with a new window, and all we have to do is drag the icon over to the applications directory. Now if you already have an older version of Tycho installed, it may prompt if you want to replace that older version. If so, go ahead and click on replace. And this process is pretty much the same on Windows. The only difference is that you'll have an installer that runs and it will install the software into the program files directory. So now that we have installed the software, we can proceed to launch it. So here I'm going to navigate to the applications directory and then scroll down to the Tycho software. And all I have to do is double click on it to launch it. And if we've never registered the software before, we may get a prompt indicating that it is operating in demo mode. And that's perfectly fine. That just means that we can experiment with it using these different data sets. So now I will go ahead and click on OK. And at this point, we can finish configuring the rest of the software. One of the first items that I like to configure has to do with what's called GPU acceleration. In other words, this is the graphics processing unit. And the reason you would want to enable it is because with it enabled, Tycho is then able to speed up certain functions by a factor of 20 or even 30 times faster than would be the case otherwise. So as you can see, by default, GPU acceleration is set to none, meaning it is not enabled. So if we want to enable it, we can go to the settings menu and choose GPU acceleration. A new window will be presented, and from here you have a drop-down menu with available choices. On Mac you have the option of OpenCL or Metal, and on Windows you have only the OpenCL option. The reason for that is that Metal is an Apple proprietary language, whereas OpenCL, as its name might imply, is Open Compute Language. In other words, it is more of an open standard. Now, when would you choose one over the other if you had the option? Well, I have found that on the older Intel Mac computers that OpenCL tends to perform better on average, whereas with the newer Apple Silicon systems, Metal seems to perform better on average. So either way, make the desired selection and then click OK to save the changes. The next item on the list is that of the known object database. So to configure that, let's go to the settings menu and choose known objects. And here we'll be presented with a new window. So the first item is that of the asteroid elements. So if we click on download asteroid elements, this will retrieve all of the orbital elements of the known asteroids from the minor planet center. Once that is completed, click on download comet elements. And then finally, once we've done both of those, we can click on verify database. Now, if you wanted to, you could also modify the settings here, but there really is no need to do so at this time. The default settings are usually optimal already. So once we're finished here, click the OK button to continue. Okay, so the next step is to configure the star catalog settings, and the way to do that is to navigate to the settings menu and choose star catalog. This will present with a new window, and as you can see, there are a number of tabs being shown near the top of this window. The one that we care about initially is the options tab. So what I like to do is to check the box labeled load catalog automatically. This is a nice convenience feature, and I would also recommend to leave the next two checkboxes enabled unless you have some reason to do otherwise, but typically the default settings are already optimal. So next, you will want to specify the desired star catalog, and you can do that through the drop-down menu here. Now once you have made your selection, then you can proceed to specify the desired magnitude band and filter. Now I will also point out that some catalogs are accessed through an online service. However, other catalogs are accessed only through an offline mode of operation. So for example, the Atlas catalog is available only through an offline mode of operation here, and it's easy enough to configure it. All you have to do is to point to the directory containing the files for that star catalog. So as an example, if I click on the Browse button, as it happens, I already have this catalog stored on my desktop folder. So all I have to do is click on Catalog Atlas Mag 20, and this is the directory that contains all of the folders for that star catalog. So all I have to do now is click Open, and you can see it has updated the path for this star catalog. Now if I want to use this star catalog, then I have to go back to the Options tab and choose Atlas from the drop-down menu. Now if you want to learn a little bit more about the Atlas catalog or about the other catalogs, simply navigate to the appropriate tab and it will give you a brief description of that catalog. For example, on Atlas, it does mention that the Sloan R magnitude band is recommended by default. So in the case of using the Atlas catalog, I would probably want to use Sloan R for its default magnitude band. So in any case, once you have made your changes, you can save them by clicking the OK button. Okay, so the next item to configure would be the tracker settings. So here I'm going to go to the settings menu and choose tracker. And there's really not a whole lot here that needs to be changed, but typically I would like to enable these two items: automatically compute the track confidence and automatically match with known objects. So again, as before, once you've made your changes, you can save them by clicking the OK button. Okay, so the next item on the list is the observatory codes. These are a list of codes maintained by the Minor Planet Center. And all you have to do is navigate to the settings menu, choose OBS codes, and then from here on this window, just simply click on the download button. This will download that list of observatory codes, and it will also inform as to how many observatories were identified. At the time of this video, there were over 2,400 observatories. So you can click OK to proceed. And lastly, if you have configured an offline version of the Find Orb software, you can also click on the button Copy to Find Orb. This will simply synchronize your list of observatory codes with the Find Orb software. Once you are finished, you can click the OK button to proceed. In the previous step, there was a reference to the Find Orb software, and indeed that is one of the configuration items that you can adjust. So to do that, navigate to the settings menu and choose Find Orb, and you'll see you have a couple of options here. One is you can use the online service, and the other is you can use a local installation of the Find Orb software. Now, when would you use one over the other? Well, there are certain advanced functions that do make use of the local installation option, but for the most part, it's easy enough to just use the online service. And what's nice about that is it also keeps the list of observatory codes in sync. In other words, you do not have to manage that yourself. Okay, so the next step is to configure the observatory settings. So the way to do that is to navigate to the settings menu and choose Observatory. This will present with the observatory configuration window. So what you want to do is to choose Action, Add Observatory. And the first item here is a label. In other words, what do you want to call this observatory entry? In other words, there can actually be more than one observatory entry, so it is a good idea to give each entry a unique label. So in this example, I'm going to give it a label of Sighting Spring. And the next section is the Minor Planet Center status of the observatory. So what is that? Well, if you are using Tycho for the purpose of submitting astrometry information to the Minor Planet Center, in other words, you wish to submit measurements of comets and asteroids to the Minor Planet Center, then it is very useful to have an MPC code. Now, if you are not interested in doing that, or you're using Tycho for some other purpose, then it is perfectly fine to specify temporary roving observer. In other words, that just simply means that you do not have an MPC code. Now, on the other hand, if you are interested in receiving an MPC code, then you would choose this option. And I would also highly encourage you to read the section in the user guide on what that process is like, as well as read the relevant material on the Minor Planet Center website. But for this example, I do already have an MPC code for this observatory, so I can go ahead and specify it here. And because we downloaded the observatory codes earlier, I can also click on this button here, and it will automatically populate the location information. Now the next step is to specify the telescope parameters. So for example, what type of telescope is it? Is it a reflector or a refractor? What is the aperture? What is the focal ratio? So you can go ahead and specify those fields as desired, then click Next. And finally, this is the last page here. What you want to be able to do, most importantly, is to specify the date obs, the timestamp information. So this is very important, especially if you are submitting astrometry information, to have the proper time encoding. So certain camera models, they may refer the timestamp to the beginning of exposure. I've never really seen one encode it to the middle of exposure, but that could happen. And I have seen some where the timestamp refers to the end of exposure. So just make sure you choose the correct setting here. If you need an offset, if for some reason your camera is not using UTC time, then you would want to have an offset such that it is. But ideally, your camera should be synced to a GPS clock, and it should be referring to UTC time. So just keep that in mind. Most of the time, you should not have to use an offset. If you happen to know the time error or the time uncertainty of your encoding, then you could check these options. These are more advanced options, so typically you can leave those unchecked. Next, you would have what kind of camera is it? Is it a CCD or CMOS camera? Next, we have what kind of precision do you wish to encode? Normally, just leave the default here unless you happen to know that your observatory is capable of extra precision. Finally, we have additional parameters. So if you happen to know the gain, readout noise, and dark current, you could specify those here as well. So once you're done, you can click the Finish button, and as you can see, it has added a new observatory entry. It is not yet active, so to make it the active entry, right-click and choose Make Active. And you can see that reflected here in the status window. It now says Observatory is equal to the label that you gave it earlier. Now, as I mentioned earlier, you can actually have multiple observatory entries. So one of the reasons you might do that is because maybe you have more than one telescope at the same observatory or more than one camera at that same observatory. So for example, you might go to Action Add Observatory, and it may be the same location, but maybe you have a different telescope, or maybe you have a different camera type or what have you. And if you were to do that, then you'd probably also just give it a different label to reflect that different camera. So that's one example. Another example, of course, would be if you actually are using images taken from a different physical observatory. So for example, maybe I want to add Mayhill, New Mexico. So I can give it another label here, and I can type in the appropriate MPC code for that observatory, apply it, and then click Next, and then Finished. And then I can toggle back and forth between these two different observatories. So that just gives you that kind of flexibility. And again, you can just think of these entries as different configurations of equipment, of telescope, of location. This next item concerns the settings for the report parameters. So we can configure that by going to Settings, Report Parameters. And these are the parameters used whenever you are submitting a report either to the Minor Planet Center or to a light curve database. So for example, this first section here concerns the persons involved in each of these three steps. So for example, you have the submitter, observer, and measurer. The submitter would be the one who is submitting or emailing the measurements. The observer would be the person who acquired the images. And finally, the measurer would be the one who processed those images and generated the measurements. Next, you have the contact email used for light curve submissions. And then next, you have an email address used for Minor Planet Center submissions. So go ahead and populate those fields as needed. And finally, you have a more advanced option here, the ability to exclude or omit magnitude information from the report. Now, when would you want to do that? Well, if you happen to have a very faint target, in other words, it has a very low signal to noise ratio, then you might still be able to get a good astrometry on it. In other words, good positional information on it, but the photometry aspect of it, in other words, the brightness of the object, you might not have a very accurate measurement of its magnitude. So in that circumstance, it would be ideal to simply omit the magnitude information when you know you have a very faint target. Now usually the default setting here is already optimal, but you have the option of changing it if needed. And then if you want to, you can make these options, these settings, unique to the active observatory. So if you happen to have multiple observatory entries, they could each have their own set of report parameters. Otherwise, if you leave this option unchecked, then these will be essentially global parameters applied to every observatory entry. So once you have made your changes, then click the OK button to save them. And then finally, we have the settings for the image directories. So if you want to, you can change how Tycho outputs the image directory. Now, normally I like to have it as the default here, which is to place the output adjacent to the input directory, but you can change that if you want to. Now, I do, however, like to change this last option here, which is to automatically load the output into the image manager. This simply saves the steps so that I do not have to manually load the output every time I do a calibration or alignment. So once you've made your changes here, click the OK button to save them, and that about concludes this video. So you've walked through all of the configuration items for the first time setup. So I want to thank you for watching and see you next time.